Now we're going to take a look at the for loop, which is also a pretest loop, meaning the condition is checked prior to entering the statements of the loop. So if the condition is false right away, then the loop will never execute anything that's inside the for loop. The structure of the for loop is slightly different than the do while and the while loop, where those two had the condition inside the parentheses, and that was it. Everything for the for loop is inside its parentheses. So let's take a look at it. Right, the keyword is for. Right, and you need a variable that's going to be used to control the loop in terms of will it execute and how many times will it execute. The for loop is the loop that's really used for counting, in terms of a loop needs to execute so many times, a counting loop of that nature. So if it's going to execute, it has to execute 10 times. Right? This is the type of loop you typically want to use. So the first thing in the parentheses, you can declare typically a variable, and we'll just call it I for now, that's going to be used to do that counting with. So we'll set it to 0 so it starts counting from 0, semicolon, and then the condition. So as long as, let's say, I is less than 10, right, semicolon again, and then the third part is how you want to change I. Right, so typically what you'll see is something of this nature, where we're going to increment I by 1. Right, and simply all we're going to do in this for loop is we're going to output the value of I, excuse me. So let's right, and we'll output I. There we go. Alright, so again, the initial condition, or initial state of the variable, the condition, like we have in all our loops, and then how that variable is changing. Right? Remember, the condition, something in the condition has to change, right, for the loop to eventually end. So this is that part of that. Alright, so this is only executed once, the initialization of the variable, and then the condition is always checked at the start of the loop, and this increment, or whatever this equation that could be here, is done at the end of the loop. Alright, so I'm going to go ahead and compile this, and you'll see that what happens, we should see 0 through 9 outputted on the screen, and that's exactly what we have. Right? So it's going to loop 10 times, 0 through 9, that's 10. Right? As long as it's less than 10, as soon as it hit 10, the condition was false, so it exited the loop. Alright, so again, this can change to be anything we want it to be. I can change this to say let's go adding 2 to it, plus equal 2, so that will add 2 to I every time, so it should loop half the amount of times basically from the first time we ran this program. Right, and there's that output, so it's at 0, 2, 4, 6, and 8, all the possible even numbers between 0 and 10. So this can be any equation you want, the changing of the control variable. Right? The I is what we call the control variable of this loop. You see I don't have curly brackets, so again that means only this first statement is part of that loop. I'm going to put another cout statement here that's going to output, let's say the value of, when we put a statement, we'll just do I times 2. Alright, it's just going to output that. And I'm not going to do it without the curly brackets at first, just to show you the result of that. I actually can't even get that far. You see that the I here has a little squiggly line under it, the red squiggly line meaning it's invalid. Why? Because the variable here is declared as part of the for loop. So the only thing that can see this variable I is something that's in the loop. And this is the only statement that's in that loop, right? Because there's no curly brackets. If I was to declare I up here, right, that issue goes away. Then I don't need this int. Alright, but this is still not part of the loop, right, as I'll show you now. So you can't declare that control variable outside, you're just going to initialize it there inside those parentheses. And you see it ran like it did before, except now we see the 20, which is the 10 times the 2, because this ends when I becomes 2. Right? That's why it's not 2 times 8, which would be 16. It's 2 times the 10 because that's what caused the loop to end, which finally executed the second cout statement there. Alright, so I'm going to remove this now again. Oops. Alright, and you see the squiggly line is back. One here because it's not declared, and once I declare it, the squiggly line should appear down here. It is. If I put parentheses, curly brackets, I mean around everything, all the squiggly lines are gone now. And now we should see 2 output statements for each iteration of the loop. It's going to output the value of I and then the I times the 2, which is what we see here. We're getting the value of 0 times 2 is 0, the value of 2 times 2 is 4, and then the value of 4, and so forth. Right, all the way to the end, we don't get a cout statement all by itself with the multiplication. We end with 8 times 2, which is 16. Even though when the loop ends, I is 10, it does not do the multiplication because the loop has ended. Alright, so again, the for loop very different than the other ones in terms of everything is done inside its parentheses. We can initialize the variable, the control variable as we call it, the conditions in there. These are all separated by semicolons except for the last one doesn't need it. And this is some equation or formula that determines how I is changing each iteration of the loop. Again, this is done once at the start of the loop, so we're coming along in main, boom, we hit the 4, this gets set to 0, and we set this condition is checked. If it's true, it comes in and does the statements. Once it's done with this statement, the second cout statement, it then will hit the curly bracket where it will do this statement, add 2 to I, and then come back up and check the condition. Alright, so that's why when I becomes 10, it checks the condition, it stops, and comes down to here and continues executing the rest of the program. Alright, so again, all the 3 pieces are in there. They're defining things. Right? Something you want to avoid, and I'll show you the result here. We'll put this back to that, and again, just show you the result so you understand what's going on, and we'll keep the window open for when I change the next thing. What you're going to show you in the next thing is that you want to avoid changing I within the loop. But you see when it runs, it does 0 through 9, multiplying everything by 2, and we get the values accordingly that are multiplied. Alright, if I was to come in here and typically this is not what you want to do, right? But maybe there is a condition where you want to do something like this, but let's say I put this in there also. Alright, oops, let's get rid of that bracket, sorry. Alright, so now I'm modifying I here, which we would do in a for loop typically. Not in a for loop, in a while loop I mean. But now this is going to give us very different results. I run this one and compare it to the previous one. Alright, this is the previous run. Alright, and here comes the current run. You can see it did it in half basically. Right, this ran 10 times, this ran 5 times. Because now I'm incrementing I really at the end of the loop twice to 2 by 2. Alright, so be careful not to do that unless that's really the intention for some reason that you need to do that. Right, but typically that's a programming error a lot of people end up doing. Right, and I'm going to just quickly show you in comparison to a while loop how we would have to change this and how a while loop would look. So I'm just going to copy this. We can do it with both, right? The for loop and the while loop. But when you're doing this kind of counting so many times that you're going to do something, we can use a for loop. This can quickly be changed to a while loop. Right, we can't do that. And I'm going to change the variable as we go along here, just so you see it's a different variable. Alright, we'll change this to a J for simplicity. Alright, and we're going to check this condition on J, and we're going to increment on J, but we're not going to do the incrementing in there because a while loop doesn't like that. We're going to do it down here. Alright, and let's get rid of this. Put semicolon at the end there, and change this to a J, and change that to a J. Right, and essentially these 2 loops are the same. Right, this is going 10 times, incrementing by 1. It's just like this, but this is all placed in one spot. Is it right or wrong to use either one? No. But this is typically the for loop is used for these style of loops where there's some kind of counting going on. Right, and there's the output. If you were to compare it one line by line, right, the for loop gives you 0 through 9, right, with the multiplications of 2, and that's immediately followed by the while loop going 0 through 9 also. So the two loops can be interchanged. This is maybe a little more compressed or shortened. Right? The amount of code though really doesn't matter in these two scenarios. The size is basically about the same when it compiles it down. So it's really doing the same thing everywhere. Right? It's just more of the look and feel inside the code for readability.